This tiny machine controls a multi-billion-dollar industry. Inside it, hundreds of precision-engineered components work together. It survives wind, speed, and extreme conditions. Let's go inside, where drones are built. Thousands of drones, moving like one intelligent system. Some entertain, others redefine modern warfare. Advanced navigation allows drones to move through complex spaces. Stability is controlled by thousands of adjustments every second. The gimbal keeps footage perfectly stable, even during motion. Every movement is calculated in real time. Once complete, drones are prepared for global distribution. This is where large-scale drone production begins. Every drone begins as hundreds of individual components. Carbon fiber provides strength while keeping weight minimal. Motors generate the thrust required for flight. This tiny board controls the entire system. Stabilization systems ensure smooth and clear footage. High-density batteries store energy in compact form. Sensors constantly analyze the surroundings. Internal wiring connects every component seamlessly. Even the smallest parts must be perfectly engineered. Hundreds of parts become one intelligent machine. Everything starts inside advanced digital simulations. Airflow is carefully analyzed to ensure stability. Every design is tested under extreme conditions. Wind resistance is critical for stable flight. Only perfect designs move forward to production. This material must be lighter than plastic, but stronger than steel. Even a 0.1 millimeter error can destroy flight balance. Symmetry here decides how stable it flies. Extreme heat locks the internal structure forever. Microscopic accuracy verified by lasers. One tiny defect, and it's rejected instantly. Thousands of frames, identical down to microns. Human eyes still catch what machines miss. This is where motion begins, from raw metal. Copper coils generate invisible magnetic force. Every loop must be perfect, or efficiency drops. These tiny magnets control thousands of RPM. If this is off by microns, vibration begins. up to 40,000 revolutions per minute, faster than a jet turbine core. Even the smallest imbalance is detected instantly. This is the brain built in dust-free conditions. Each dot smaller than a grain of sand. Thousands of components placed every minute. Heat transforms loose parts into permanent circuits. AI scans every connection faster than the human eye. One faulty board can crash the entire drone. This chip processes millions of calculations per second. Even static electricity can destroy components. Now, assembly begins. Motors are installed with exact torque control. Every connection must be perfectly accurate. Piece by piece, a machine becomes alive. Next, the drone is programmed. Now, it learns how to fly. GPS ensures precise positioning in real time. At first, everything looks perfect. Every movement precisely controlled. Thousands of calculations happening every second. But even a small disturbance can change everything. A tiny imbalance starts to push it off course. If one motor fails, even for a fraction of a second, the entire system collapses instantly. Unless it can correct itself in time. Within milliseconds, the system reacts. Hundreds of corrections executed instantly. When everything works perfectly, it feels effortless. This is not just a machine. This is precision in motion.